Hello, everyone. So, in this lesson, we're going to be talking about roots. Chapter 1, Lesson 8 is all about roots. What is a root? Well, you know what a square is. If I took 2 squared, that would be 2 times 2, which equals 4. And 2 to the third power would equal 2 times 2 times 2, which equals 8. So, if I ask you what is 2 squared, you'd say 4. If I asked you what 2 cubed was, you'd say 8. If I asked you what the square root of 4 is, you would tell me it's 2. If I asked you what the square root of the cubed root of 8 is, it's 2. So a square root is any number times itself, but a cubed root is any number times itself 3 times. Try that again. Let's talk about some perfect squares, okay? So 1 squared equals 1, 1 times 1. 2 squared, 4. 3 squared, 9. 4 squared, 16. 5 squared, 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared, 100. 11 squared, 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. And 15 squared is 225. Okay, so notice that we have gaps in between here. So 1 squared is 1, 2 squared is 2. But if I asked you what the square root of 1 is, what times what is 1? The answer would be 1. And the square root of 4 would be 2. And the square root of 9 would be 3. And the square root of 16 would be 4. But notice there are numbers in between here. We're missing the square root of 2 and the square root of 3. We're missing the square root of 5, the square root of 6, the square root of 7, and the square root of 8. And the square root of 10, 11, 12, 13, 14, 15. So you can see that while our counting numbers are going up, the number we're getting the square root for is not, we have gaps in between. So when we talk about a perfect square, 1, 4, 9, 16, 25, and so forth, these are perfect squares. These are perfect numbers. They are made of multiplying a number times itself. Square roots are what times what equals that number. You can only take square roots of perfect squares. So you can only take square roots of 1, 4, 9, 16, 25, 36, 49, 64, and so forth. But what if you needed a square root of a number that wasn't a perfect square? Well, then you have to estimate it. So roots of perfect squares, remember, those were rational numbers, but roots of non-perfect squares are irrational numbers. Let's try what that means. The square root of 1 equals 1. This is a natural number. This is a whole number. This is an integer, and it is rational. The square root of 2, the square root of 3, the square root of 4. Oh, now we go to 2. See, these are in between. 2, this is natural. This is whole. This is an integer, and it's rational. But these guys right here, they're not, they're in between 1 and 2. It's going to be 1 point something or 2 point something. And if we looked at a calculator, we'd find out that the estimated value of the square root of 2 is 1 point, let's see, 1.2? 1.2, oh, I'm sorry. It's 1.414. And the square root of 3 is approximately 1.73 and so forth. These are non-terminating, non-repeating decimals. That makes these guys irrational. We can only estimate their value because they are not perfect squares. Okay? So only perfect squares can we take square roots of. Also, we should note square roots can only be taken of positive numbers. Why is that? 1 times 1 equals 1. 2 times 2 equals 4. 3 times 3 equals 9. Negative 1 times negative 1 equals 1. Negative 2 times negative 2 equals 4. Negative 3 times negative 3 equals 9. Notice that your answers are positive. When you multiply a number times itself, you always get a positive. A positive times a positive or a negative times a negative. Either way, your answer is positive. So if you take the square root of one of these numbers, the square root of 4, the square root of 9, you're going to get either 2 or negative 2. It's possible I multiplied negative 2 times negative 2. It's possible I multiplied positive 2 and positive 2. The square root of 9, likewise, could either be 3 times 3 or negative 3 times 3. But I can't take the square root of a negative number. Why? What numbers make up negative 4? What are the factors of negative 4? Negative 1 times 4, 1 times negative 4, 2 times negative 2, or negative 2 times 2. I didn't write the same number. This is not, we don't use these. But even if we're looking here, it's 2 times negative 2, or negative 2 times 2. Negative 2 and positive 2 are not the same number. This has no solution. You cannot take the square root of a number that is negative. Only can take square root of a number that's positive. Okay? Positive numbers only. Now, if I tell you that, say, x squared is equal to 144, this means x times x is equal to something times something. Whatever I put on this has to be the same thing. So an x times x equals 144. 144 is 12 times 12. So each x is equal to 12. Or it could be negative 12. What about if I said a squared equals 64? What you're going to do is take the square root of both sides. The square root of a squared, this is the square root of a times a. This is going to be the square root of 8 times 8, or the square root of negative 8 times negative 8. You have to take a square root, you got to have two of a kind. I have two of a kind, so this becomes a. I take one of these for 8, I take one of these for negative 8. So a squared equals 64, a equals either 8 or negative 8. Now when we see this, a negative, remember this is positive 8 times positive 8. The shorthand way in math of writing this is a can either be positive or negative 8. So this plus or minus sign on top of each other, that means it's either a is positive 8 or a is negative 8. It's one of those symbols you have to get used to. Plus or minus means both positive and negative answers are accepted. All right? Now you guys are off the hook for doing cubed roots this year. They decided that we would just want to focus on those things that we can. But let's take a look at some other examples. What if I gave you, say, the square root of 1.69? And what if I put a negative out here? Well, that negative sign is outside the square root. That's okay. We're going to take that negative sign and just put it into our answer. Now, if I looked at this as 169, I would find out that that's 13 times 13. I have 2 decimal places, so I will go 1, 2, and that's the 2 decimal places. So instead of 169, it's 1.69. So instead of 13 times 13, it's going to be 1.3 times 1.3. So the negative square root of 1.69 would be 1.3. Now, why did I not say the positive? Because I specifically asked for the negative by putting a negative sign out here. All right, what about if I gave you something like this, where I had a fraction? What if I said 4 over 25? So a squared equals 4 over 25. So you would take the square root of both sides. You take the square root of 4, you take the square root of 5, because these are like 2 separate things. So what does that give us? The square root of a squared is a. 4 is either positive or negative 2, and 25 is either positive or negative 5. So this would be a equals positive or negative 2 over 5. All right, let's try another curveball. What if I gave you the square root, asked you to give me the square root of negative 144? 144 is 12 times 12. But that negative sign means that I have no solution. Okay? Okay, so with that negative 144, again, no real solution. So if you had the square root of negative 36, the square root of negative 49, the square root of negative 100, whatever, as soon as you see a negative sign inside the square root, inside the radicand, you know that there is no real solution. Now, this time I said real because it is actually truly no real solution. There is a solution to this, but you'll learn that in high school. As far as you're concerned, there's no solution or no real solution. Okay? And that's all there is to roots. Let me know if you have any questions. Good luck.